Hello one and all, it's time to share the second video on arithmetic progression. This is the problem number 7 of exercise 7b. The ratio of sum of m terms and n terms of an AP is m square ratio n square, so that the ratio of mth and nth term is 2m minus 1 ratio 2n minus 1. Now let AP is AA plus DA plus 2D, you already know. So according to question, the sum of m terms is m by 2, 2a plus m minus 1d, and n terms, the sum of n terms is n by 2, 2a plus n minus 1d. This is m square by n square given. So cancel this m by this and m by this and 2 by 2. So we are left with 2a plus m minus 1d by 2a plus n minus 1d. This is m by n. Now we have to find out Tm by Tn. Tm is a plus m minus 1d and Tn is a plus n minus 1d. But we are given 2a. Here is simply a. We have to find out a, but our information is in 2a. So multiply 2 and divide by 2. This is 2a plus 2m minus 1d and 2a plus 2n minus 1d. Now 2a is matched with 2a. 2a से match कर गया. So m minus 1 must be replaced this by this. We need 2m minus 2, but here m minus 1 is given. So replacing this m minus 1 by 2m minus 2 to get the same. So replacing m minus 1 by 2m minus 1, and at the same time we have to replace this m. So m by this 1 will be transferred to this side. So replace m by 2m minus 2 and this will plus 1. So 2m minus 1. Similarly, n minus 2 is in denominator, but we need 2n minus 2. So replace n minus 1 by 2n minus 2 as the requirement. So and n is also replaced. If minus 1 is added to this side, it becomes 2n minus 1. After that, this becomes 2a already, and this is replaced by 2m minus 2d, and this is replaced by 2n minus 2d, and the m by n is replaced by this 2m minus 1, n is replaced by 2n minus 1. So our proof is ready. This is the proof. Now moving toward the next problem. Next problem is 8th number problem. Question number 8. This is the sum of first P, Q, R term. The sum of first P, Q, R terms are ABC. So we have to prove that A by P, Q minus R, A by P, Q minus R plus B by Q, R minus P, C by R, P minus Q is equal to 0. Now see, the sum of P terms is A. So AP will never start with A. So let the AP is capital A plus D, capital A plus 2D, and so on. Because the sum of P terms is a small a, so AP will never start with a small a. Now according to the question, the sum of P terms is A. So according to question, SP is equal to A. Sum of P terms is A, and we know that SP is equal to P by 2, 2a plus p minus 1d. This is equal to a small a. Now we have to find out a by p. So this p is transferred to this side. We get half of 2a plus p minus 1d is equal to a by p. So we have got a by p. This a by p is ready now. Similarly, we have got SQ is equal to B. SQ is equal to B, but SQ is equal to Q by 2, 2 capital A plus Q minus 1D. and this is equal to b. So we need b by q. So this is half. Q is transferred to that side. Half 2a plus q minus 1d is equal to b by q. So b by q is ready, a by p is ready, b by q is ready. Similarly, SR is given c. Sum of r terms is given c. So this is r by 2a plus r minus 1d. This is equal to c. But we need c by r. So this r is transferred to right side. So we are left with half of 2a plus r minus 1d is equal to c by r. Now starting from LHS, see here that a by p is the requirement, b by q is the requirement, c by r is the requirement, a by p, b by q, c by r. So putting all in LHS, so starting from LHS, put the value of a by p. So a by p is equal to half of 2a plus p minus 1d into q minus r plus, similarly putting the value of b by q is half of 2a plus q minus 1d into, now after that r minus p plus, similarly moving towards the last c by r is equal to this. So half of 2a plus r minus 1d into this p minus q, and simplify it to get 0 RHS. It's your duty to simplify. The main portion has been done. After that you can simplify it to get the value 0. If you are not capable to simplify due to a scarcity of time, simply you will write 0. We get 0 on simplification. Now the most urgent problem, number 14. This is the most urgent problem, urgently required. If S1, S2, S3, Sm are the sum of n terms of MAPs. There are MAP, S1 से लेके SM तक MAP. So to show whose first terms are whose first terms are 1, 2, 3 and M, and common difference differences are 1, 3, 5, 2m minus 1. Prove that S1 plus S2 plus Sm is equal to half Mn plus 1. So there are MAPs. So if first term is answered, so answer is available here. If A is equal to 1, D is equal to 1, then S1 is equal to, if first term 1, common difference 1, then S1 is equal to sum of n terms, n by 2, 2a plus n minus 1 into D is also 1. Now similarly, if A is equal to 2, D is equal to 3, then our S2 is n by 2, 2 into 2 plus n minus 1 into 3. And lastly, no need to write all the terms. These are the symbol of succession. If A is equal to m, D is equal to 2m minus 1, then Sm is equal to A is equal to, the last term is m and D is 2m minus 1. The Sm will be n by 2, 2a, A is m plus n minus 1 into D is 2m minus 1. So we are going to add this. All are adding S1 से लेकर के Sm तक का एडिशन. So S1 plus S2 plus dot dot Sm is equal to, see with care, n by 2 is common everywhere. So keep n by 2 common. After that 2 is common everywhere. So keep 2 common. Then 1 plus 2 plus m. 1 plus 2 plus m. Bracket closed. Plus. Then n minus 1 is taken common. N minus 1 is taken common. After that 1 plus 3. 1 plus 3 plus dot dot 2m minus 1. The last term is this. Now we have to find out the sum of this. Both are in AP. So you know how to find out the sum. I have told you how to find out the sum by fastest formula. Sum is equal to L plus A, L minus A plus D by 2D. By using this, we can find the sum easily. So this is n by 2, and if the sum is calculated by this formula, this will be m into m plus 1 by 2 plus n minus 1. And if the sum is calculated by this formula, this will be simply m square. Now let us simplify this. When this is simplified, 2 cancel. Now n by 2, this is n by 2, bracket m square plus m square plus m, then m square n minus m square plus m square n minus m square. So this m square is cancelled and m is taken common. So this is mn by 2. And after that, m is common, so 1 plus mn. So this is the proof. The proof is successful. Now your problem may be how to find out the sum of this and this. You can check. You can check if you are interested. So just checking, or no need to check. You know how to use the quick formula. S is equal to L plus A, L minus A plus D by 2D. Suppose you have to find out the sum of 1 plus 3 plus 2m minus 1. Then this will be L. L is this, 2m minus 1 plus A is 1 into, then L minus A, 2m minus 1 plus D. D is 2. The common difference is 2 by 2 into 2. So this cancelled. So we are left with 4m square by, common difference is also 2. So this is 4m square by 4. This is m square which I used. Now the next one is this is also urgently required from exercise 7b. The problem is 13. This is very important and urgent problem. Again, urgently required. If mth terms of AP is A and the nth term is B, nth term is a small b, then so that the sum of m plus n terms, so the sum of m plus n terms is equal to m plus n by 2, a plus b plus a minus b by m plus n. This is higher order problem, students. The AP will never start with a small a because mth term is a small a. So let AP is solution. capital A and so on. Let this is your AP. Now according to instruction, mth term is A. So according to question, mth term you know A plus m minus 1d. This is capital A is equal to a small a given. Mth term is A plus m minus 1d. This is small a, and nth term is capital A plus n minus 1d. This is a small b. On subtracting, just subtract this. 1 cancel, a cancel. So this is m minus nd is equal to a minus b. So d is equal to a minus b by m minus n. So this is the value of common difference. Again, write the two equations also according to question. A plus m minus 1d is equal to a small a plus n minus 1d is equal to a small b. Here we are going to add. So this is 2a plus m plus n minus 1 d is equal to a plus b. Now just see, there is a technique keeping this at a time. Why this at a time is being kept? This is m plus n minus 1d minus d is equal to a plus b. So why this d has been separated? When d is multiplied with 1 and d is multiplied with this, there is a reason. Just now you will know 2a plus m plus n minus 1d is equal to a plus b plus d. Now moving towards our target, Sm plus n. We have to find out Sm plus n. Now we are going to find out Sm plus n. This is m plus n by 2 to 2a plus m plus n minus 1d. Now a student, it is very clear that 2a plus m plus n minus 1d is ready to us. The whole thing is ready to us. That's why I separated this minus 1 and sent it to the right side. So this is m plus n by 2. Now putting the value of 2a plus m plus n minus 1d from 1, it becomes a plus b plus d. And the value of d you will substitute from here. Put d and get the value. So if d is substituted, Sm plus n will be equal to m plus n by 2. This is a plus b, and d is this. Putting d, a minus b by m plus n. It should be m plus n, students. No, m minus n. This is a minus b. So let me check first. M minus n. Yes. So this is a minus b by m minus n. So this is proved. The checking is over. Now moving towards another. Another is the new thing, arithmetic mean. This is arithmetic mean. Arithmetic mean. Arithmetic mean is symbolized by m. So what is the arithmetic mean? To find one arithmetic mean, between a and b. a b के बीच में एक arithmetic mean निकालना है. So let a is the m between a and b, between a b. Then a b. A और B के बीच में a m है. So in a p there is a character of arithmetic mean that if it will be substituted in between the two a and b, it will form the AP. So this implies a minus a is equal equal to b minus a, and hence this is 2a is equal to a plus b. So a is equal to a plus b by 2. So arithmetic mean between two numbers is the sum of two numbers by 2. Thank you very much. More voice is coming from outside. Thank you. In the next video.